This lesson is over how to solve prediction and comparison problems. In other words, given a word problem, can you solve through proportion or through a table or through graph? So let's look at our number routine. Jessica can do 60 sit-ups in 2 minutes. Wow. Dell can do 150 sit-ups in 5 minutes. Are these rates equivalent? Can they do the same number of sit-ups per minute? So many ways you can do this. I can build up from 2 minutes to 60 sit-ups by 30. I can do it the same way here times 30. So they are equivalent. Another way I can do it is I can find a unit rate. I can break this down per minute. Each minute, 1 minute. So Jessica can do 30 sit-ups every 1 minute. And also, if I divide both numbers by 5, Dale can do 30 sit-ups in 1 minute. So they're equivalent. So they make a proportion. A proportion are equivalent rates, ratios, or fractions. So let's look at our do now. At the school book sale, Michael bought 3 books for $6. Darnell bought 5 books for $10. Do these rate form a proportion? Let's see. 3 books. It's so important you label these. $6. Or you can literally say $6 for $6 3 books. 5 books. $10. So how do you turn? We could do it this way. How do you turn 3 books to $6 times 2? How do you turn 5 books to 10 times 2? So they are going to form a proportion because they are both. If you simplify this, it's 1 book for $2. This will be 1 book for $2. So they do make a proportion. Another way is, so this will simplify to 1 book, $2, and this will simplify 1 book to $2. So a proportion are equivalent ratios, equivalent fractions, rates. So your child, if you are watching this, there's this website called Hit the Dot. You will go to this website and you will try to, it's like whack the mole. If you ever go to carnival games, it's whack the mole. You try to hit the mole head as fast as you can, and each time you hit it, you get tickets. So the same thing. So imagine we had 5 students who came up here, and they all hit the mole. So one kid did 11. Another kid did, I don't know, 14. Another kid did 23. I'm just making up numbers right now. So student 1 hit 11. So let's write that. Hit 11 dots in 30 seconds. If student 1 keeps the same rate, how many dots will he or she hit in 90 seconds? So do I want to make a table? So dots and seconds. So we know 11 dots, 30 seconds. 22 dots, 60 seconds. 33 dots, 90 seconds. I could have made a graph of this. Or, to save time, can 30 seconds, what's the scale factor here? What can I multiply 30 seconds by to turn it into 90 seconds? Times 3. That's why 33. Student 2 hit 23 dots in 30 seconds. If student 2 keeps the same rate, how many dots will he or she hit in 3 minutes? So 23 dots in 30 seconds. Seconds. How many seconds are there in 3 minutes? See, a minute 60, a minute 60, a minute 60. That's 180 seconds in 3 minutes. Can 30 seconds be built up to 180 seconds? Times 6. So the scale factor is times 6. So what is 23 times 6? 6 times 3 is 18, carry the 1. 138 dots in 180 seconds or 3 minutes. But so today we're going to be learning something called proportion. we can set up a proportion is equivalent ratios or equivalent fractions. So it's so important that when you do a proportion, you label it so you know what you're going to be using. So it's 23 dots, 30 seconds. I'll be honest, it's almost like a table. A table is a little more straightforward. That's why many students say, I prefer writing it as a table. But we need to know that this is equivalent to this. So what do you multiply 30 to get 180 seconds times 6? And hence, 138 dots in 180 seconds. One of the students hit an even number of dots. Really? 14. Oh, okay. 14 dots in 30 seconds. Who was it? Third student. If this student keeps the same rate, I mean to keep the same pattern, how many dots will he or she hit in 45 seconds? Can 30 even go into 45? No. I guess 1.5. But you know what? I don't want to work with decimals. Could I break this down to 7/15? I divide a numerator and denominator by, oh goodness gracious, I divide a numerator and denominator by 2. So it's 7 dots, 15 seconds. Now can I build it up to 45 times 3 times 3? So the scale factor is time. Scale factor at first was times 1/2. Now or divide by 2. Actually, scale factor needs to be multiplied. And then I multiply by 3, so that's where I get 21 dots in 45 seconds. Again, some of you may prefer doing a proportion instead of doing a table. I don't really care one way or the other. So that's a D, by the way. So can 30 seconds go into 45 seconds? No, we had to break this down to 7 dots, 15 seconds. Then I build it up by 3, and that's where I get 21 dots in 45 seconds. One of the students hit an even number of dots in 30 seconds. Let's just say it was 22. Who was it? If this student keeps the same rate, how many dots? So 22 dots in 30 seconds. If this student keeps the same rate, how many dots will hit in 75 seconds? Can 30 go in 75? We have to break this down. We're going to multiply by a scale factor of 1/2. Or another way of saying that is divide by 2 because reciprocal, remember? Reciprocal dividing by 1/2 is times 2. So now can I build it up to 75? Times 5. The scale factor is times 5. And that would be 55. Some of you may not like using scale factor. You may go to 11, 15, and then you make another table. So 11 dots, 15 seconds. 22 dots, 30 seconds. 33 dots, 45 seconds. 44 dots, 60 seconds. And 55 dots, 75 seconds. Some of you like me putting a table. And you can set this up as a proportion down here. Again, the most important thing I'm going to say about this, you got to label it. That's a D, by the way. This is an S. It's so hard to write on these using a mouse. So can 30 go into 75? Some of you may even say multiply by 2.5. I prefer not working with decimal. I prefer to break it down to 11/15, then build it up by 5, and that's where I get 55 dots in 75 seconds. Goodness gracious. Alright, so Alex read 4 pages in a book in 6 minutes. How long would you expect him to read 6 pages at this rate? So some of you may prefer the bar diagram. You just like drawing a bar. So imagine this entire bar is 6 minutes. There are how many pages? 4 pages. So we need to divide this into 4 sections. So each section represents a page. So we have 6 minutes, and we need to divide it into 4 sections. Let's figure out how many minutes go in each section. Can 4 go into 6? 1 time. If I subtract this, 6 minus 4 is 2. I need to get rid of that remainder. So you put a 0.0 because with that, you don't change the value of 6. I bring it down. Can 4 go in 20 5 times? So it's 1.5. So 1.5 minutes, first page. 1.5 minutes, next page. 1.5 minutes, third page. 1.5 minutes, fourth page. So, in other words, there are 1.5 minutes for each page, per page. So, predict how long it will take to read 6 pages. So 1.5 plus 1.5 plus 1.5 plus 1.5 plus 1.5 plus 1.5, that would be 9 minutes. 9 minutes each page. Or I could just done 1. I know I can read 1.5 minutes per page. I can multiply 1.5 times 6 and get that 9.0 or 9 pages. Some of you may not prefer the bar diagram. You may just prefer using a table. I like tables. 4 pages, 6 minutes. Wait, is that? Let me go back. 4 pages, 6 minutes. Yep. So the question is 6 pages. Make sure, do you understand why label is so important? I almost put the 6 on the bottom. Pages right here. So can 4 go into 6? It cannot. Can I simplify this? Yes, I can divide both numbers by 2 or multiply by the scale factor 1/2. Now can I build it up? Times 3. So how do you turn this? Times 3. So that's where 9 minutes come from. God, that's so much faster than a bar diagram. Again, some of you may prefer writing it as a proportion. So it's PM, pages, minutes. So we have 4 pages, takes 6 minutes. We need to figure out 6 pages. Can 4 go in 6? No, we have to simplify it. 2 and 3. Now build it up by 3, and that's where the 9 minutes come from. So Sarah can type 90 words in 4 minutes. Let's break this up into 4 sections. About how many words would you expect her to type in 10 minutes? So if I have 90 words and divide it into 4 equal sections, I do not know that. 90 divided into 4 equal sections, 20. That'd be going 2 times, 22. Oh, remainder. How can I put it without getting changing the value of this 90? Put a 0.0. Can 40 go into 4 go into 20 5 times? So it's 22.5. So she can type 22.5 words every minute, per minute, each minute. So we know it's 22.5 per minute. Then if you multiply 22.5 times 10, you'll get 225 words in 10 minutes. What if you write a table? Words and minute. Word. So it's 90 words, 4 minutes. I need to figure out 10 minutes. Can 4 go into 10? No. Hey, let's do a shortcut. Oh, no shortcut. Yes, can I simplify this? That would be 45 in 2 minutes. I divide the numerator and denominator by 2. Now can I build it up? Yes, I can. Multiply by 5. And that's where 45 times 5 is 2. Oh, goodness gracious. 225. Again, so we have a bar diagram. We have a table. Maybe you prefer writing it as a proportion. So label it. Words, minutes. Words, minute. So it's 90 words, 4 minutes. All right, that's supposed to be M. So 10. Can it 4 minutes go to 10 minutes? No, we have to simplify this. That's where we get 45 over 2 times 5, and that's where you get the 225 words in 10 minutes. All right, next example. Mr. Joe, I cut 120 flowers from 4 bushes. At this rate, how many roses will I cut from 10 bushes? Yellow is Lucy Liu's favorite color. It's from the TV show Encyclopedia. So let's see. This is about roses and bushes. So 120 flower roses come from 4 bushes. If there are 10 bushes, how many flowers will my deer receive? So, I'm going to do, we could do between, can 4 go in 10? But I want to do a within. I think this will save time. Can 4 go into 120 times 30? So 10 times 30, the answer is 300. And I'm done. It's 300 roses and 10 bushes. I like that. So sometimes you can multiply within. Within is up and down, or between, left to right. It's up to you. In a survey, 3 out of 5 people prefer jelly over peanut butter. There are 120 people at the grocery store. Use their survey to predict how many people in the store would prefer peanut butter. So this is about jelly and peanut butter. So I'm going to label it jelly, peanut butter, and people. So 3 out of 5 people prefer jelly. So 3 people like jelly. So that means 2 people like peanut butter out of the total of 5 people. There are 120 people. So where would I put 120? On the bottom right here. Use the survey to predict how many people in the store would prefer peanut butter. Can 5 even go into 120? Yes, it can. There are many ways you can do this. I don't know. You know what? Could I do it this way? Can I double this and make times 2, make this 10, make this 4, and make this 6? So I multiply by 2. So I'm going to do a slow build to 120. So I multiply by 2. Now, because I honestly, I did not know. I don't know. I'm a teacher, and I don't even know how many 5s go in 120. I mean, I could figure out. But I'm going to do a slow build to it. Can 10 go into 120? I know that. That's times 12. So 4 times 12 is 48. 6 times 12 is 72. So 72 people like jelly, 48 people like peanut butter, and 120 people like, are there 120 people? So what's the question again? How many people would like peanut butter? 48 people. Greg can wash. So now, what if you don't like table? I'll be honest, I really like tables. Fine, I'll use proportion. Greg can wash 4 windows in 30 minutes. So this question is about what 2 things? Windows and minutes. So 4 windows, so the rate is 4 windows in 30 minutes. How many windows can you wash in 2 hours? What's another way to say 2 hours? 60, 60. That's 120 minutes. Can 30 minutes go into 120 minutes? Times 4 times 4. So the scale factor is times 4. So it's 16 windows, 120 minutes. Or 2 hours. So now choose which method you prefer. Do you like tables or proportion? I like both. But sometimes I like table because it's a little more straightforward and there's a lot more room to work with. There are 12 boys and 8 girls in Mr. Thomas' class. At this rate, if there are 800 students, how many will be girls? So this question is about boys, girls, and students. So how many boys are there? 12. How many girls are there? 8. How many students are in this class? 20. They want us to build it up to 800 students. Can 20 be built up to 800? Do you want to do a fast build of times 40? Or do you want to do a slow build? Times 5. I want to multiply by 5 first and get 100. Times 5 is 40. Times 5 is 60. Now can 100 go in 800? Times 8. So 40 times 8 is 320. 60 times 8 is 480. So the answer is there are 480 boys, 320 girls, 800 students, so the answer is 320. So in a bag, the ratio of oranges to apples. Oranges, apples, and I see fruit somewhere. So the ratio of oranges is 3, apple is 7. So how many fruits are there in that bag? 10 fruits. How many oranges are in the bag if there are 50 fruits? So we need to build up to 50 fruits. So that's times 5. So that's be 35 here times 5. 3 times 5 is 15. So 15 oranges, 35 apples, 50 fruit. So this is the study of proportion using word problems. You may set up as a table, you may use bar diagram, or you may write it in a proportional form like this. Along you understand that a proportion is equivalent fractions or ratios or rates, that this needs to equal this. So you sometimes can multiply between or within, up and down or sideways. And this is just it.